Good morning, students. I welcome you once again to the discussion of a few more topics from the chapter of sound. In the previous lesson, I had told you about some characteristics of wave motion. So today we shall discuss primarily how sound can be called a longitudinal wave, how sound propagates in a medium, and try to understand how it travels through different media. Why sound wave is a longitudinal wave. Now for this we can take the example of a vibrating tuning fork. Now you can see in this picture, when a tuning fork is set into vibration, how the particles of the medium arrange themselves. Now let me tell you that this particular setup of a tuning fork, the two ends which has been marked A and B, these are called the prongs, and the base, this is called the stem of the tuning fork. Usually some numerical values are assigned here, so they are marked with numbers like 256, 384 or 512. So for example, a tuning fork of number 512 means that its prongs on hitting a rubber pad produces 256 vibrations per second. Okay, so when the tuning fork is struck against a hard rubber pad, the tuning fork begins to vibrate at its set frequency. So when the prongs move about these two positions, they compress the layer in contact with it. So the volume of these layers decreases and pressure increases. So this pressure difference crosses the compressed layer to move forward. So you can see how the layers are arranging themselves alternately in the form of rarefaction and compression, ultimately reaching up to the observer. So when the sound is traveling through any medium, actually the particles of the medium are arranging into alternate layers of decreasing and increasing density than the normal value. So this is just the situation for a longitudinal wave. In a longitudinal wave, during the propagation of a longitudinal wave, we find regions of compression and rarefaction, alternate regions of compression and rarefaction. So that's why it is quite obvious that we should call sound a longitudinal wave. This diagram gives a much better understanding of how ultimately the layers are arranging themselves. Let us have a closer view. You can see the different positions. So in this manner, the compression and rarefaction in a longitudinal wave are moving. So that is the direction of propagation of the wave. So how sound travels in a medium? Sound travels in a medium in the form of compression and rarefaction. So as I told you, we shall try to figure out the requirement of a medium for sound to travel. Now this is a very basic setup that is ultimately employed to prove that sound needs a material medium to travel. Sound requires a medium to travel from the source to the listener. The matter through which sound is transmitted is called a medium. The medium could be a solid, a liquid, or a gas. For example, when a doorbell rings, the sound travels through air and reaches our ears. We can also say that the speed of sound is maximum in solids, followed by liquids, and least in gases. We shall be discussing it about the speed of sound in the coming lessons, but right now I would like to tell you that sound cannot travel through vacuum space, and as you can see that it can be proved with the help of a simple experiment. What shall we do in this experiment? In order to prove that sound needs a medium to travel, you can refer to the setup. You have to place an electric bell inside a glass jar and connect it to a battery. Now when the switch is closed, sound of the bell is heard. It's an electric bell. This hammer is going to hit the gong and you can listen to the sound being produced. Now one end of this glass bell jar is connected to a vacuum pump. What is the purpose of this vacuum pump? Obviously to extract air out of this jar and create vacuum inside this jar. So now let the air be removed from the jar with the help of this vacuum pump. What shall be our observation? We shall observe that loudness of the sound slowly decreases as the air is removed. Gradually the loudness of sound will go on decreasing. Ultimately, what should happen? Finally, no sound is heard when there is no air in the jar. So, what can we infer from this experiment? We can infer that in the absence of air, sound was unable to reach from the source to the listener. This means sound cannot travel through vacuum. Exactly for the same reason, sound cannot reach from space because there is vacuum in the space for the propagation of sound. There is absolutely no medium, and sound cannot travel if there is no medium. Sound can easily propagate through solids. As you can see in this experiment, it is propagating through this string. Or if the surface of this table is hit and you press your ear on the surface of the table, then the vibrations, you can listen to these vibrations. It travels from one end to the other end through this solid wooden table. Sound can easily travel through solids. Sound can also travel through fluids, be it air or water. Like in this experiment, you can see that a watch has been placed inside this balloon filled with water, and the boy has pressed his ear against the surface of this balloon. So the ticking sound of the watch can be easily heard by the boy. Or if you just put some steel spoons inside the water and hit them together, you will be able to listen to the sound. See, in this picture there is a siren, and the sound of the siren is heard equally by both the observers. It can be heard by the person through this medium, air. So the sound can travel from the siren up to this observer through the medium, air. And similarly, the sound of this siren can also travel through water and can be heard by this observer who is inside water. But obviously, the sound requires a medium, and if there is vacuum, no sound is going to be heard by the observers. So sound can travel through solids as well as through fluids. But as I told you, that the speed with which sound is traveling in different media, that is going to be different. The question arises, why it is going to be different? This is due to the arrangement of particles in that media. Now for this you need to just apply a little bit of understanding of chemistry. You have studied in chemistry that in solid, liquid and gases, the arrangement of particles is different. So obviously in solids, the particles are tightly packed. So there is a very easy transfer of energy from one particle to another, and that's why the speed is more. The interparticle separation in liquids is higher. In case of liquid, it is a bit more than solids. So it will take more time for the energy to reach from one particle to another. So the speed will decrease. And in gases, the separation further increases. So obviously the speed is going to decrease. So that is the basic reason why sound travels fastest in solids, a little bit slower in liquids, and slowest in gases. But sound can travel through all the media. It cannot travel through vacuum.